and welcome back to AGT STEM. Today we're going to be watching a video on Roentgenium? Roentgenium. I don't know. I'm just guessing at this point. Anyway, let's get into the video.
I'm sitting in the control room of the GSI Institute, the control room of the linear accelerator that was used to create element 111 and 5 of the other super heavy elements. The idea of this is that you have a metal target, usually lead or bismuth, elements 82 or 83, and you take a lighter element, say copper, and bang the copper at huge velocity into the lead or the bismuth, depending the element that you want to make. The idea is that you have to accelerate them very fast so that the two positively charged nuclei can come together, but not so fast that you have a lot of energy and they immediately fall apart again.
Okay, this is the periodic table of the elements that was used for the christening of element 111, which was called Roentgenium. And you see, you can remove this cube here. And Sigurd Hoffmann, the head of the group who discovered the elements, and our minister, Annette Schaman, together inserted the cube into the periodic table of the elements, and it actually started to glow. Ah. Oh, it was an amazing day. We had a huge ceremony. 1,000 people came here for the christening. Afterwards there was cake and champagne, and it was really good.
Element 111 has a name which is really difficult to pronounce, Roentgenium, which is named after Röntgen, the discoverer of X-rays. I just find that it's a combination of letters that people in England find difficult to pronounce. However, Röntgen was, I believe, the first Nobel Prize winner, or one of the first Nobel Prize winners, and so it is really quite fitting that he should have an element named after him. The first discovery was of 3 atoms of this element, and then the experiments were repeated and another 3 were found. So it was still relatively quite a small number. But it's very important when somebody does a series of these experiments that you have to repeat them to make sure that you've really seen what you think you want. You're really excited, you want to make a new element. And so it's quite easy to fool yourself. Or sometimes people could be tempted to cheat. So you really have to repeat it. Ideally, you get a different lab in a different place using a different route. And if 2 people get the same results, you're pretty sure. But in this case, I think the 2 runs were repeated here. And it was still a whole period of 10 or 12 years between the discovery of the element and it being finally named, because people want to be absolutely sure that the data are correct. The machine that makes these ions is enormous. And it takes a whole team of operators to control it. And all this stuff behind me is to control the power, the voltages, and so on the different parts of the accelerator that takes the ion beam to this tiny chamber. It's really only about this size where the actual experiment took place. And once the atom is made, it then flies off to a detector that's 2 rooms away down a long tube.
Yeah, of course, we are waiting now for the final confirmation to christen element 112, which is going to be copernicium. But, well, we don't know yet what we're going to do for the christening. We're having discussions what we're going to do, and I think it will be a big surprise.
I wonder how old this video is, because it says they haven't made, like it said that they haven't made copernicium yet. But also, we figured out how to say it. I can't even. Roentgenium? Probably saying it wrong. But it doesn't say how old the video is, so Thank you so much for watching, and we'll see you next time. Stay smart. Bye!